This question is given that 6 identical conducting rods are connected as shown in figure. Point A and D are maintained at a temperature of 200 and 20 respectively. The temperature of junction B is. So for the calculation purpose, we can easily find out the answer by using a nodal analysis. In nodal analysis, we need to identify the nodes, and let's say if you want to find out the value of temperature at point B, so we can observe with respect to point B. So let's say the resistance of each and every conductors are identical, so each and resistance of each and every resistors are same. So let's say resistance of each and every resistor over here is equal to R. Now we can say that we can identify which resistance are in series and which resistance are in parallel. You can observe that these two resistors are in series and these two are in series. So while combining these two resistance, we can take it as a single resistor of resistance, let's say that is 2R. And while combining these two, we can take it as single resistor of resistance 2R. Now we can observe that these two resistors are connected in parallel. 2R and 2R in parallel. That means the equivalent resistance is going to be nothing but R. So now we can just consider that there is a point A, and we are having a resistor of resistance R, and another point take it as B. While combining these two resistance, we can consider a resistor of resistance R, and here we are having point C, and there is another resistance, take it as R, then we have point D. Now we can observe that these two resistors are connected in series. So while combining these two, we can just consider that there is a single resistor of resistance R plus R, which we can take it as 2R, and there is a point over here, take it as D. Now we know the temperature of point A is nothing but 200, temperature of point D is nothing but 20, and Rm is to find out what about the value of temperature of this point B. Now we can just use nodal analysis for point B. So while considering that the temperature at point B is equal to X, so we can write the equation for it, that is X minus 200 divided by resistance of this, that is R, plus we can write X minus 20 divided by resistance between them, that is 2R, should be equal to 0. So we can write this is like if you are taking this 2R as nothing but its LCM. So you can multiply here with 2 and here by 2. So this 2R will cancel with 0. So remaining thing we can take it as 2X minus 400 plus X minus 20 is equal to 0. Or you can write this 3X is equal to nothing but 420. So we can find out the value of X over here, which is equal to nothing but 420 divided by 3, which is equal to 140.